All right. So today we're going to finish up talking about loops by doing maybe one or two exercises, depending on how much time we have. And then by the end of the day, we'll go ahead and start on the next topic, which actually encapsulates a lot of different topics where we actually start creating our own functions. We're going to be covering functions, prototypes for functions, modularity, how to split your functions out into separate files, into separate libraries, like you witnessed when you built that Capra car project on on your homework. There were multiple different files, and we provided you a make file to bring all those things together. So it's modularity, in other words, keep separating things out into different files so you don't have everything in just one big giant file. That'll also entail understanding how functions work on a much lower level, a fundamental level, using passing by reference and passing by value, which means that we have to cover something that is unique to C, which are pointers. And so it's going to take us the better part of 2 weeks to cover all of that stuff. And that's why it's, I forget how I labeled it, but it's I think it's still split up into two modules because it also involves error handling. But before we get there, let's go ahead and finish up the discussion here on loops. We left it off looking at several pitfalls, off by one errors, in which case you'll have to either change where you start or change your continuation condition where you end. Infinite loops and how to kill them and how to avoid them. Missing brackets that can ultimately lead to infinite loops here. And the last example that I want to show you, the last example of a pitfall that I want to show you, is the following piece of code. So before I give you the name here, let's look at it and see if there's anything wrong with it. To the naked eye, to the beginner, you might not necessarily see that. In fact, even to the expert level C programmer, it might not look it might not be apparent right away what's wrong with this code. But you know what? Let me go ahead and cut and paste it, and let's bring it into REPL. And let's actually execute it. All right. So get rid of that and put that in there. All right. Let's run it. All right. So it's not printing anything, but it is actually running because the stop button is right here. What do you think is wrong here? We're caught in an infinite loop, exactly. Right? So why are we caught in an infinite loop on this example? Let me expand it out and get rid of this so that we can see it a little bit better. And let me go ahead and fix the styling there. So int I is equal to 0. That's our initialization statement. We start at 0. While I is strictly less than 10, now do you see what's wrong? We've got a semicolon there. Remember, we had this exact same pitfall with conditionals. If I is equal to 10, then do something. But if we put a semicolon there, what did we end up doing? What do we end up doing here? While I is less than 10, do the next executable statement. Well, what is the next executable statement? Nothing. Right? So while I is less than 10, do nothing. I is still less than 10, so do nothing. I is less than 10, so still do nothing. That's why it's caught in an infinite loop over here. And it's still running. It's doing nothing, right, infinitely. So let me go ahead and stop that. And what's the problem? The problem is unnecessary, in fact, wrong semicolons. Right? Remember, the description again is the above code will get caught in an infinite loop doing nothing. A while loop, like a conditional statement, binds to the next executable statement, bool statement. In this case, the next executable statement was, oops, let me go ahead and fix that spelling there. Executable statement was empty because of the semicolon. Right? There we go. Sorry, I'll type a little bit better here. All right? Again, that semicolon should not be there. It's syntactically correct, It'll compile. It may or may not even give you a warning, even if you put on the WAL flag. You just have to keep your eyes out and follow good, consistent styling. And if you do that, it'll immediately look weird because, wait a second, there should just be a space there, not a semicolon. If you're consistent about your styling and you get used to looking at one particular style, then odd things like that will tend to jump out at you a little bit more, right? But of course, you'll notice it right away when you get caught in an infinite loop, and then you have to kill it. Remind me, how do we kill it on the command line? Control-C, good. All right. One other thing that you'll eventually have to use are nested loops. Right? So often, you may need to have more than one iteration. Right? You may need an iteration within an iteration. You'll definitely eventually need this, and we'll revisit it at that point, when you need to iterate over a two-dimensional array, basically a matrix, or a table. If you've got rows and you've got columns, you need a way to iterate over for each row, and then within a row, you need a way to iterate over each column. And that will that's taken care of by nested loops. I'm just going to go ahead and cut and paste this example here, and that's what we'll take a look at. So I've got two index variables here, I and j. Again, I is just the idiomatic letter that we use for index variables because index starts with I, and it's really not modeling anything. It's just a counter variable that we're using to iterate over a loop. So it makes sense that, well, if I use I and I need another one, I'll use j. If I need a third one, what do you think I should use? K, right? And so on and so forth. Generally, you don't want to use L because, as many of you already noticed, if you had trouble connecting to your Samba share, seeing a lowercase l, it's hard to distinguish between that and a 1. So you want to avoid L in general when you're using fonts like this. But otherwise, I've got two variables here, and I've got two loops, a loop within a loop. The outer for loop runs I from 0 up to what? Does it go up to 10? What does it go up to? 9, because it's strictly less than 10. The inner for loop also runs 0 up to 9, but it runs it on j. For j running from 0 up to 9, strictly less than 10, up by 1, we'll go ahead and print out a combination. We're just going to take I and j and print out their sum. So on the first iteration, what does this print out? I is 0, j is 0. So their sum is going to be 0. On the next iteration of the inner for loop, j has incremented to 1, but I is still 0. So it's going to print 1. On the next iteration, j goes up to 2, then 3, then 4, then 5, etc. I is unchanged here at 0. Right? Only after the inner for loop is completely done executing 0 through 9, and so their sums would be 0 through 9, does the outer for loop then increment to I is now 1. Right? And then j runs from 0 up to 9 again. So it'll be 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3, etc., all the way up to 9. 9 plus 1 is going to be 10. How many times total does it do this? On the inner for loop, that runs 10 times, 0 through 9. The outer for loop runs 0 through 9. So if the inner for loop runs each time for the outer for loop, how many times are we looking at here? How many things are printed out? 100. 10 on the inner for loop, 10 on the outer for loop. The inner for loop is executed each time. So when the first time, the second time, the third time, each one of those is 10, 10, 10, 10, 10. 10 times 10 is going to be 100. Right? And so you can nest for loops and run them over however many times you want. If you've got 3 nested for loops, okay. You might be doing that for some algorithm or something. If you've got 4, 5, 6, no. Rethink what you're doing. There's probably a much better way to do this. Okay? So one nested for loop, in other words, 2 for loops here. This is you see this a lot, right? 3, you don't see that as often. 4, again, you probably want to rethink what you're doing. You're probably doing something wrong, right? All right. So again, the above code iterates for 10 times 10 equals 100 times. All right, there we go. And you can go ahead and run it in your own browser if you want, or you can run it in REPL. You can do whatever you like with it. So I've got two exercises here. First of all, I'll call your attention to several of the exercises that are given, or that are part of one of the the videos that are part of this course. I go through 3 or 4 exercises there. I think I go through something similar to this first exercise here. And so if you want to run over it again, there's a video there to do it. Otherwise, there are several other exercises that we run through. The second one, we don't have a video of that, so that's going to be new here. And it's going to be very similar to Hack 4 that you're going to be doing tomorrow. But I wanted to do these brief exercises first just to get some more practice writing loops. Sometimes these are called coding kata. That's K-A-T-A. Kata is something, I don't do martial arts, but if you do martial arts, you might have heard of this. A kata is like the Karate Kid, wax on, wax off, right? It's a common exercise that you repeat over and over and over again just to get used to it, to have that muscle memory. These are kind of kata in that they're simple exercises that you do them, they're drills. You do them over and over again, and writing loops will be second nature to you. Right? So I want to go through each one of these exercises. Let's write a loop to list even numbers 0 to n, 1 to a line. To do that, I'm simply going to go over to REPL. And hopefully that's big enough for everybody, otherwise I can increase the size here. Let me go ahead and get rid of this. All right, again, I'm going to go a list of even integers, 0 to n, 1 to a line. Which kind of loop do we want to use here? A for loop or a while loop? Which one do you think is more natural here? A while loop? Okay. Who said a while loop? We want to defend that. Why? Okay, so if we don't know how many times, do we not know how many times? N, right? N's a variable, right? We would read it in from a user, or I mean, it's a variable, so no, you're right in the sense that we do not know what the value of n could be on any run of the program, but we do know that it will have a value, so it's a fixed value that it'll run through, right? So I'm going to go ahead and go with a for loop, because we know exactly how many times we're going to run up to n. Well, not exactly n, but 0 to n, but only for even numbers. So I'm going to go ahead and put in just a regular old for loop here. Int I is equal to, I'll start out at 0. I is less than n, I plus plus. Well, I do need an n here, so let's go ahead and just create n, and I'll say that it's equal to 20 or something. Okay? And I'll go ahead and print it. Printf, %d, and the line I. Right. Now, let's go ahead and run this. It doesn't give me what I wanted, right? It gives me 0 through 19, right? Let's fix this loop. That's just a regular old for loop that goes 0 up to, and not including n, which has the value of 20, by 1, printing it out each time. What are some things I can do here to ensure that I do get what was specified? Only even integers, 0 up to and including 20. Yeah, way back there. Okay. If. How do I test if something is even? If I is even? I take integer division and the remainder is 0, then it's even. And I'll print it out. All right, let's run that. All right, well, now I'm only getting even integers, but I'm missing that 20. So what's the other fix? Yeah. Oh, hold on to that thought for a second. Let's fix the other thing before that. Yeah. Less than or equal to n. Let's run that. And that works. Right? Now, is there an improvement? I plus equals 2. Or another way of writing that would be I is equal to I plus 2. Go up by 2's each time instead of going up by 1 each time. Or as you put it, use the compound assignment operator to do the shorthand there. Let's go ahead and see what that does. All right, that's good. If I do that, do I need that conditional check anymore? Now I'm counting by 2's. I'm going 0, 2, 4, 6, all the way up to n. Right? So now I've simplified this by skipping out, by taking out that middleman. Right? Let's get rid of that. All right, there we go. Great. Two fewer lines of code, right? Remember KISS. Keep it simple, stupid. Right? Make sure that you are reducing the amount of code so that you reduce your cognitive load, the things that you have to look at and read and understand. Okay? All right, what's the next kata here? The same list, but delimited by commas instead of one to a line. I'm going to go ahead and leave this here. Can I do this? Yep. Ooh, nice. REPL allows me to go ahead and block comment out. Most IDEs will allow you to block comment out by just selecting something and then going either, on my Mac here, it was command and then / to comment out every single line at once. And then I imagine that you can undo that by doing it again. All right? So for, I'm going to use the exact same for loop there. So let me go ahead and cut and paste for the second one. But instead of printing out one to a line, I'll put in a comma instead. Let's see what that does for us. That looks nice, except for what? Yeah, the comma on the end. That looks weird, right? If this were an English paper and you had a trailing comma, would that be okay? That'd be like a little red X for you, right? So let's get rid of that. How can I get rid of that? Yeah. If I is equal to 20, or just keep it general. If I changed n to 30, then that wouldn't work, right? So if it's equal to n, then we know that we're on the last iteration, so we'll do something else instead, right? Okay. If this, and then, of course, don't forget your curly brackets. So if it's equal to n, then we won't print this. We'll print, say, well, let's go to the next line, right? That'd be a good thing to do. Else this. All right. I hope that'll work. Yep, it looks like it works. And let's go ahead and try changing the value of this. If it's 30, it works. If it's 31, what would you expect here before I hit the play button? You would expect it to print out 0, 2, 4, 6, all the way up to 30, right? Okay. Without that trailing comma? Oh, all right. Good suggestion, but it didn't take care of all cases. This is a corner case where n is not an even number, but we still want to go up to, but not including it. The loop takes care of that for us, right? So, another idea. Handle all the cases. Yeah?
Make your if statement if I is greater than or equal to n?
Okay, I could generalize that if statement. If I is greater than or equal to n, then I don't print out the comma. I only print out the end line character. Still didn't work. Why? Think about how this loop is running. It runs up to 30, right? And it's not equal, so it prints out the comma. And then it goes on to 32, jumping beyond the n. And that's when we break out of it. Okay? Simplify, right? What if I took care of the last iteration separately? Right? That's one common solution to those off by 1 errors. If you have to do the same, same thing for the first 10 values, but the last one that's a special case. Well, write your loop for these first 10 values, and then just take care of that last case afterwards, right? So I will go ahead and change this so that it's always printing out a comma here. Let's see what that does. Again, that takes us back to when it's 30. Instead of going up to and including n, let me go ahead and go up to maybe just 1 less, right? I don't know. 1 less, 2 less, I don't know. And then we'll go ahead and printf, %d, and the line. What should I print here? Yeah. Okay, we'll come back to that. I'm going to go ahead and print I. Let's see what happens here. Crossing my fingers. What's wrong? I doesn't exist, right? I made a loop. I scoped I to the loop, right? Remember that you can do this on the CSE command line as long as you're using that flag that we posted about the other day. And I'm using it here except for when I do this, I doesn't exist after the loop, and it doesn't exist before the loop. So if I want to do a solution like this, then I need to make it exist before the loop. Right? And now let's see if this works. Still crossing my fingers here. Right? All right. Well, now we're off by 1. Solutions. What do you mean complete for it? All right, how about yeah, suggestion right there.
I would make an if statement if n modulus 2 is equal to 0.
Okay, so how about we just check to see if I is the last one that we need to print, right? If I is equal to n, then we will print this out, right? We could do that. Let's find out if that works. Well, that got rid of the 32, but I'm now back to square 1. We still have that comma there. Remember, I'm going up by 2's in my loop? 0, 2, 4, 6, 8. Where do I really need to stop? Yeah?
You could put the whole thing in an if statement, and then if n is odd, subtract 1.
Oh, wow, okay. I don't want to go to that much work. I don't want to write that much code. Yeah? How about, okay, you could, you were correct in that I is less than n minus 1. I'm going to go up to and including n minus 2. How about that? That's the same thing. It's just do you put 1 on this side or do you put 1 on that side? And then you would have a strictly less than or a strictly less than or equal to or something. All right, let's see if that works. All right. Ooh. Less than or equal to 29. That doesn't get us there. So that's what you meant, probably? Or let's find out. All right. Oh, that still doesn't work. All right. Oh, in the if statement right here? Okay. If I is less than or equal to n, like that? Minus 1? Okay. Oh, or let's go up to less than or equal to n, strictly less than n. And then if let's try this. Nope. All right. If I is less than or equal to n, it won't be because we broke out of that loop, right? So we're going up by 1s, right? This was our original, okay? How can we change it so that we get that last iteration? Think about this. If we go 1 less, then instead of less than or equal to, it's just strictly less than n, right? Oh, yeah, go ahead. Oh, what, here? The previous value. Oh, without the if statement. Let me go ahead and keep the if statement for a second, and let's see what that does. Right? That prints 30 twice. Right? So let's see what that does. 30, and then end the line. We do want to print it, so this logic is correct, right? Well, no. This logic is incorrect if it's. Let's see. What do I want to do? We're off by 1 here. We have to figure this out. Okay. Well, let's see what it prints without the if statement. All right, that's 32, right? So what if I went up to n minus 1? Oh, not minus 2, excuse me. There we go, right? Again, I want to handle that last iteration separately. So since I'm going up by 2s, I need to make sure that that last iteration, 30, I'm going 28, then 30. I need to make sure that that last iteration doesn't happen. What's the last iteration then that I want it to happen at? 28. So that would be less than or equal to n minus 2. Now on the next iteration, after this, after we break out of it, then we've got this value right here. Okay? There might still be some issues there, but let's go on to the next one. Issues as in, like, you can clean it up a little bit more. Although that's pretty concise code there. A list of integers divisible by 3 between 10 and 100, and print a total out as well. So I've already got I here. Oops. I'm going to preserve that so that you can take a look at it. Oh, actually, it's in the video, I think. So 4. Again, another for loop here. We'll start where? Let me go ahead and bring this up so that we can read it. A list of integers divisible by 3 between 10 and 100. So where do I start? OK, I could start at 10. But 10 is not divisible by 3. What's the next thing that's divisible by 3? 12. OK. I is less than or equal to 99, because that's the last thing between 10 and 100 that's divisible by 3. And then go up by I is equal to I plus 3, or what's another concise way of writing that? Plus equals 3. Good. Printf, %d, and the line, and I. Right, let's see if that does that. There. 12, 15, 18, ... all the way up to 99. No if statements here, no handling of that last one. If we had gone up to like 10 to 99, then we would have had to make a superfluous check to see if is this actually divisible by 3. Right? That's a very concise. It doesn't get more concise than that for that exercise. Oh, and then print a total as well. So if I'm going to have a total, I should have a variable. What should I call that variable? Total? OK. Right. Let's leave it like that for a second. And what should I be doing inside the loop to add that value to the total? Total is equal to total plus I. What's another more concise way of doing that? Plus equals I. Right? And then let's print it out, printf. Total is equal to %d and the line, total. And let's run it. So total is 1665. I think that that's correct. Of course, you can take out your calculator, do a little bit of algebra to verify that. But it might not always be correct. Look at line 17. Between line 17 and 18, what value does total have, the variable total? I don't know. Good. Shrug. Who knows? It could be 0. In fact, in this case, it was 0. But that's because whatever REPL is doing in the background is providing a default value for your variables. C does not define a default value. If you took this and put it on a Windows machine using probably MinGW or Cygwin, you could get a garbage value. What is garbage plus 3? Garbage. What is garbage plus 7 or plus 5? It's still garbage, right? So what should I have done here instead to make this correct C code? I should have initialized this to 0, because you start out a sum at 0. In some systems, I don't remember if I covered it, but in some systems, even for uninitialized variable values or uninitialized memory values, they use the term dead beef. Dead beef is just simply hex speak, dead beef. Right? What can you spell with the letters E through F? Because that's a hexadecimal. Hexadecimal is base 16, uses 0 through 9, and then A through F. So what can you spell with it? Well, you can spell hex speak, right? What can you spell with hex speak? And of course, sometimes you can use the 1 as an L or an I or something like that. So dead beef. There we go. Dead beef. Is frequently used to indicate software crash or deadlock in embedded systems, et cetera, et cetera. It's a special flag value to indicate that it's uninitialized. And so you could be getting dead beef plus 3, dead beef plus 6, right? And it's going to be some nonsense value, right? Try to take this code and run it on a different operating system with a different compiler, and you could get completely different results if you do not initialize your variables correctly, right? Even on the same system, sometimes I've seen different runs get different values. Right? All right. Print all positive powers of 2, 1, 2, 4, 8, up to 2 to the 30th. Right? So what kind of a for loop do you want to use? Or what kind of a loop do you want to use here? For loop or while loop? For loop, okay. For I running where what? I is less than something, I plus plus, maybe something like that. Printf, something something. Right? So tell me where you want to start here. I could start at 0. Why 0? 2 to the power of 0 is 1. Then the next one, 2 to the power 1 is 2, right? 4, etc. So you're using this index value as the exponent, right? And so we'll go up to and including 30 by 1. And so we'll have 2 to the I, here I'll go ahead and print that out, print I out, is equal to, all right, how do I actually compute 2 to the I? Compute 2 to the I. How? Can I do this? 2 to the I. I've seen people try to do this before in C. That's not valid C. And some programming languages allow you to do that, right? It's working here, but for weird reasons. It's interpreting that as a bitwise exclusive OR. So it's taking the binary value of 2 and then doing a bitwise exclusive OR with it and getting weird results there, right? And it's not actually printed it out because I didn't put another placeholder in there, but I'll show you what it does. It's going to print out the same thing over. Oh, yeah. It's going to print out weird stuff all the time because I is changing. Right? Those obviously are not correct. Right? So I cannot do that syntax. How do I go 2 to the I instead? Okay, I could use pow. Raising 2 to the power I. If I do that, what library do I need? Include the math library. Right? Let's see if this works. Wow. Garbage, garbage, garbage. 0, 0, 0, 0. What's wrong? Yeah. Pow is not what? It'll still work for this. It should still work for this. You're right. It is returning a double, but then you would just expect truncation because it's going to be a full number, right? Okay, back to the drawing board. Let's think of something else. Let's suppose that I don't know what's wrong with POW. We'll come back to it. What's another alternative? Instead of keeping track of POW, or instead of using POW, you now live in a world without the math library. So yeah. Okay, so if I started out with 1, right, and I multiplied by 2, what would I get? 2. Now I've got 2. What if I multiplied again by 2? What would I get? 4. What if I multiplied by 2 again? 8. Then 16, and I've run out of fingers. So what if we created another variable here, right? Int result, say. Okay. And then each time I went result is equal to result times 2. I doubled it, right? I started out somewhere, and each time I double it, I go from 2 to 4 to 8 to 16, etc. Right? Now what happens when I print out result? Always 0. Why? I didn't. Where did I start out at? 0. What's 2 times 0? What's 2 times 0? You're never changing. Where should I start it out instead? 1. Right? And now let's print this. Okay, that looks good, except for one of those off by 1 errors yet again. Right? We've got 2, 4, 8, etc., but those clearly are not lining up. So what should I do instead? What's the order of operations within this loop? You multiply it by 2, then you print it. You multiply it by 2, then print it. If I started out at 1, though, what should I do instead? Print it, then multiply it by 2, so that the next iteration through, I have what I want to print out. All right? So let me go ahead and change the order there. Right? And when I do that, 1, 2, 4, 8, dot, 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 2 to the 30th, I don't know if that's correct or not. Let's ask Google. And that looks correct to me. Right? What if I went one more? Is 2 to the, let's ask Google. Is 2 to the 31st equal to negative 2.147 billion? No, it's equal to positive 2.147 billion. Look at the last number there, 8. And over here, it was also 8. So it's this correct number, but now we're getting negatives. Why? The integer maximum value was 2.147 billion, which is 2 to the 31st minus 1. In other words, 2,147,483,647. We went up by 1. What happens? What do we call that? What happens when you take a cup of water and you fill it with 2,147,000,000 things, right? And now it's too full, so the next time you add another drop of water, it overflows. Right? That's what's happening there. That's why we only went up to 2 to the 30. Right? If you wanted to, you could change this to a long, if you remember your lab 2, right? And I think that this is going to, LD I think was what it's going to want. There. Now that's correct. In fact, you can go up to 63 or 62. Yep. And that indeed is 2 to the 62nd. Right? I'll undo that, though, because that wasn't part of the, oops, and then only up to 30. Good. Print all even integers 2 through 200 on 10 different lines. So in other words, 2, 4, 6, 8, all the way up to 10, and then go to the next line so that you only have 10 numbers on one line. Right? That's the last one, I think, right? Well, forget about reverse order. Yeah. Probably because I don't have access to the actual backend here, so it's not LM. It's probably not linking in the math library, but it's still compiling, right? So that's something to talk to them about. if there are I don't know, settings, all right, they're not compiler settings, so oh well. Right? Theoretically, yeah. I mean, if you want to, we can go ahead and try this on the command line here. Emacs foo.c. And instead of result, you wanted to do pow of 2 to the I. All right, there we go. Get rid of. We can get rid of that, and we can get rid of that, and hope that gcc foo.c. Fine, int I, and also include the math library. All right. Oh yeah. All right. LD. I'll just go with that. It might still complain to me about it, but it should still work, right? No, it's not. All right. And this is not CSE. Okay. I'll have to look at it further, but that was my suspicion, and that was wrong. All right, let me go ahead and get rid of this, and let's take care of this last one. Forget about in reverse order, so let me get rid of that. There we go. Print all even integers 2 to 200 on 10 different lines. Okay. For I running from 2, I is less than, let's say 200, I plus plus, printf, %d, we'll just go with spaces this time, and I. Well, that's going to print what we want, up to and including 200. and I'm up by 2. I think I said even integers, right? Plus equals 2. So that'll work. But if I expand this out, that's all in one just giant line, right? What I want is something that looks more like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I want something that looks like this. There. All right, so now I'm done, right? No, it doesn't work that way. The last line especially is only 5 there, right? So how could I cut it down to the next line after every 10th value? Okay, create a counter. All right, that's the suggestion I just heard. Int count is equal to 0. And we'll say if, I'll always go ahead and increment it by 1. And if count is equal to, well, if I started out at, if it's equal to the 10th thing that it's printed, then I'll go ahead and printf an end-line character. Okay? Let's go ahead and do that. All right. That worked for the first line, but everything after, it didn't. Why? My counter is counting the number of things I've printed, right? So if I'm going up by 1, up by 1, up by 1, it gets eventually to 10 and prints that end-line character. But then what, on the next iteration, what value is the counter? 11, 12, 13, 14, etc. So what should I do if it prints out that end-line character? I should reset it, right? It's a counter that's counted up to 10, end the line. Now I should go back to 0. So count is equal to 0. And let's see if that worked. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, that looks good. So it does what I want it to. Is there another alternative way of doing that? Yeah. Oh, okay. You could, instead of having to reset it every single time, you could say that if it's divisible by 10, then go ahead and print this. Let's see if that works. Works on the first one. Does it work on the last one still? 3, 4, 5, 6, 7, 8, 9, 10. Okay. Slightly simpler code by getting rid of one line, right? Could we incorporate, could I get away without the counter entirely? When does it need to break to the next line? 20, 40, 60, 80. What's the pattern there? When they're all multiples of 20. So if I mod 20 has a remainder of 0, then I also go ahead and print the end-line character. Right? I get the same result, but now I don't need the counter at all. Right? Much simpler code. In general, prefer simpler code. Cut your code down until you've gotten rid of all the cruft. Remember, cruft is the garbage that doesn't need to be there anymore. All right, simplify your code until it is simple enough. Not until it's just one line of code, cryptic code, because you were clever about doing a bunch of variable manipulation and stuff like that, or you just took the entire idea and crammed it down to one line of code. One line of code is not readable, right? Unless it's a very simple thing that you're doing. So if you've got a long piece of code, try to cut it down. Try to cut it down and simplify until it should not be simplified anymore, right? That's where the art comes in. That's where it's kind of subjective, right? If it's a difference between a 4-line piece of code and a 5-line piece of code, now you can get into a debate with somebody if you really want to. But if it's a difference between a 4-line piece of code and a 50-line piece of code, there's definitely one person that's wrong there. Or if it's the difference between 10 lines of code that are readable and 1 line of code that's all cryptic and you have to really strain to understand what's going on, then there's clearly one better right there, right? But the difference between a 4-liner and a 5-liner, that's just a healthy debate, okay? You want that, what we call the Goldilocks zone, right? That's in more than just computer science. It's in the planet Earth is in the Goldilocks zone. Where's the Goldilocks zone with respect to the sun? It's Earth, exactly, but it's not too close to the sun. It's not too hot, And it's not too far away from the sun. It's not too cold. It's right in the middle. It's Goldilocks, right? Like her soup. That porridge was too hot. That porridge was too cold. This porridge was just right. So that's the idea with coding. That code is too long. That code is too short. This code is just right. Right? All right, good coding, Kata. I'll go ahead and leave it like that. And then our last exercise will be to write a full program here. Let's write a program to project the total earnings in a savings account with a fixed APR, initial balance, and monthly deposit over a specified number of years. Okay. To do this, I wish I had a better whiteboard, but I don't know how to use that. So instead, I'll go up here on this board. Let me go ahead and just pause this for a second, and then screen up. All right. So just in case you don't know how savings accounts work, let's go ahead and write down a test case. We're going to understand how this problem works by whiteboarding it. This is not a whiteboard. This is a traditional chalkboard, but it's called this process is called whiteboarding. You write down an example, or you work through a problem with one or two people there by writing it up on the board. Instead of just if you're alone, you can just do it on a piece of paper. But if you're with somebody, it helps to put it up on a board so that you can both go back and forth and talk about it. Right? This is whiteboarding. So suppose I've got an initial balance of, say, $10,000. Right? That's how my savings account starts out that way. And suppose that I've got an APR, that is an annual percentage rate of 2%. Right? That's almost usual right now for CDs, at least. And suppose that I commit to making a $100 deposit each month. Right? Now, how does this work? After the first month, how much money do I have? So after the first month, have I earned a full 2%, $200 on this $10,000? No, it's only the first month, right? You only get 1/12 of this. Right? So after the first month, you have $10,000 in interest times 2% over 12, because there are 12 months in a year, right? You can pull out your calculators and find out what that is. I'll do it on the computer here in a second, or somebody can shout it out to me. So this is your interest. Then you also put in an additional $100. So at the end of the month, you would expect to have, I think it's $16.67. Right? There we go. Right. This right here should be $16.67, right? Or it should be $16.66666 ... Is that how money works? Can you have $16 and then 2/3 of a penny? Nope. So what happens? Okay, chop that off. That's what the bank would like. The bank doesn't have to pay that extra 3/4 of a cent to you. What would you like to happen, though? Round it up. All right. There. Now, what banks actually do, I don't know. There are FEC, or not there are rules that govern what they have to do, etc. I won't worry about that. For our purposes, we'll go ahead and round up and give you that extra cent. Okay? In month 2, the interest compounds, meaning that we don't earn 2% on the $10,000. We earn 2% on that $16 of interest, or almost $17 of interest, plus that monthly deposit that we made last month. So we have $10,116.67 times 2% over 12 months. Somebody can pull out their calculator and tell me what that is, or I'll go over here and do it. Anybody? $10,116.67 times 0.02 is 2% divided by 12. So it's $16.86. Right? We round down, all right, and to be consistent. Is that correct? I think $16.86. Right? So $16.86. So therefore, after we add our monthly deposit, we now have $10,233.60. entry. There. I won't go any further, but you could go as far as you want to understand the problem. Not only do you now understand the problem a little bit better, but now we have a test case. And these are the things that you need to be doing for your hack. A test case is something that you write down on a piece of paper or that you come up with some other solution, a calculator, Google, Wolfram Alpha, the supercalculator, etc. And you know that it's correct by some means other than your program. This will allow us to test the program that we're about to write to see if we're correct. Okay? Rather than just assuming that we're correct. Okay. So I've got a shell program here. Savings. There we go. This program computes a savings account growth over a specified number of years, given an APR, initial balance, and monthly deposit. It produces a monthly report. Something like that. Okay? Now, just to get some more practice in here, do you want to do this interactively, or do you want to do this as command line arguments? Command line arguments? Okay. So how many command line arguments should we expect? So APR, initial balance, APR, and monthly deposit. 4. And the number of years that you want to do it, right? So initial balance and monthly deposit, and maybe I should put that in the a given number of years. Did I just not? A specified number of years, APR, initial balance, monthly deposit. There we go. So it is 4. Except for argc should be checked against 5. Because you've got those 4 inputs plus, what's always the first argument? It's the executable file name. So if I don't get my 4 arguments from them, then I'll go ahead and print an error message. Error. You need to provide years, APR, initial balance, and monthly deposit, and the line. And how do I exit on them? Exit. Right? How do you quit on them? You just exit. Otherwise, I'll take those 4 arguments in that order that I've specified. Let me go ahead and put this back down here so that everybody sees it. Come on. Practically have to break this thing. All right. And I will, so for the first one, let's say years. Should it be a double or an integer? Years. You could go for a half a year. But I want just an amortization table here. I'm going to go for 10 years or something, or I'll retire in 30 years or something. I'm going to go ahead and go with an integer. A to I, or I should have asked that. How do I convert from a command line argument into an integer? A to I. And which one is it going to be? The second one, so that's at 1. Right. What's the next one? APR is going to be A2. Oh, should it be an integer? Nope. Double. Okay. Why a double? Because what is 2%? 0.02. Right? And if I want to convert to a double, what do I need to use? A to F. RB is at 2. That's the next one. Then we've got, what else? Initial balance. A to F. I'm making that a double because you could have $10,000.50 as an initial balance if you really wanted to. Right? And double, what's the last one? Monthly deposit. A to F of RB. So 4. There we go. All right. Now I've got my years, my APR, my initial balance, and my monthly deposit. Okay? But we need to write a loop to get that kind of a table there. What kind of a loop do you want to write? A while loop or a for loop? Do we know how many times we're going to execute this loop? If I said that I want to tell how much money I've got in 5 years, right? We know years. That's going to be 5. How many months am I going to want to run it for then? 60. Right? So let's do a for loop. For int I. I'm going to start it at 1. Because if I want to print it out like this, the first month is not 0. The first month is 1. I'll start at 1, meaning that I've got to go up to and including years, times how many months in a year? 12. I plus plus. There we go. Okay. And I'm going to print out the month. I'm going to also print out exactly what I had up there. The interest, %F, will come in and clean this up here. Maybe not commas there. And then new balance, right? So I've only got 3 columns here to print, and then I'll end the line. I've got to figure out what to print there. All right? So let's write it out as comments here. Let's compute this month's interest. How do I do that? How did I do that up on the board? I took the current balance, multiplied it by the APR divided by 12. Right? So it's going to be the current balance times APR divided by 12. How do I turn that into code? I need a variable to store that first of all, right? So let's create a variable called month interest. I don't want to call it monthly interest because that would mean that it's the same every single month, right? This month's interest. I could call it this month's interest, but that's getting kind of verbose. That's long. So just month interest, or M interest if you really want to shorten it. And it'll be the current balance times APR divided by 12. Strictly speaking, that 0.0 is not necessary because they're all doubles, but I'm driving home the point that it's going to be divided by 12 and that they are doubles. Do I have a variable to hold the current balance? I have a variable to hold the initial balance, don't I? But the initial balance, that's something that probably doesn't change. The new balance is what changes every single month. So I'm not paying by the variable here. Let's create another variable called balance, or you could call it current balance. Right? And now I've got this variable that I can multiply by. Where should I start my current balance before the loop begins? Should I start it at 0 like we did in the coding kata? No. Initial balance. You get credit for what's already in the account. All right? So there's the initial balance. There's the month interest. So I'll go ahead and print those out. Oops. I missed something. Oh. Eagle eyes. What is that? That's a colon, not a semicolon. Right? There we go. Right, there we go. The fact that Emacs forced me to indent, that's what told me that there was something wrong above. Right? Month interest, and then current balance. Right? That's what I'm going to print out. Let's see if this works. Good, error checking. Let's go ahead and use what I had up here on the board as our whiteboarded solution. Years, well, let's just go out to 10 years. My APR was what? 2%. My initial balance was $10,000. And my monthly deposit, I committed to doing $100 a month. Right. Okay. So the first month, the first 2 numbers worked, sort of. And the last number definitely did not. Right. So we've got to do some sleuthing here. What do you think is wrong? Let's walk through this. Right. So I've computed correctly in some sense the first month's interest. It matched our number up here. It matched the number that had 66666 repeating, right? We'll come back to how to fix this in a second. The third number is the number that was wrong. This number right here should have been $10,116.67. Why did it print out $10,000 over and over and over again? We compute the month interest and then print it out. What else do we need to do? What did I do up here on this board? Computed the month interest, then I added it to the current interest, or to current balance. And did I do that in my code? No. Nope. So, current balance is equal to current balance, you don't lose anything, plus month interest. Interest, there we go. Is that correct? So I'm adding that $16.67 in. And so I get $10,000, $16.67. What else am I missing though? The monthly deposit. Right? So plus monthly deposit. There we go. Let's go ahead and run that again. Oops. There we go. All right. Did it match? The first iteration it matched somewhat, right? We still have these lingering numbers over here. The second iteration, did that match? Well, 233 and 52 cents, but well, it should have been 53 cents. What's not happening here? It's not rounding, is it? So let's go ahead and fix that next. What should I round? There are a couple of things here that I could round. I could round the monthly interest. Probably want to do that. I could round the current balance. But if you assume that the monthly deposit and the initial deposit are already rounded in the nearest cents, and you're only adding in the monthly the monthly interest, the month interest, then and if that's rounded too, do you need to round the entire balance? Probably not. So let's go ahead and round the month interest. How do I round? What do you think? Is there a way to round? How do I round in C? I should probably RTM, right? Read the manual. Man, round. How do I round? Oh, hey, in the math library, there's a round function. Let's use it. There are several round functions. We're going to use that one, though. The month interest is equal to round month interest. Okay? So let's see what this does now. Oh, what did I forget? Include the math library. There we go. And rerun this. There we go. All right. Looks like everything's rounded to me now. Is it? That first month you earned $17. Wow, that's generous, right? They gave me an extra 33 cents. What does round do? It rounds it to the nearest whole number. Right? So, all right, well, now we're sunk because read the manual as much as you want. There is no round to cents function. Right? The first question that this will come up when we start covering functions. What's the first question you should ask yourself when you're trying to solve a problem? The kind of question that I implicitly answered when I went to the math library. What's your problem? After you know what the problem is, what do you ask? Think laziness here.
Is there already an answer?
Is it already solved? Right? Is there something there that already solves it for me? And that's what I did when I went to the math library. Is there a function that does this for me already? Not exactly, but it does round to the nearest whole number. I want to round to the nearest hundredth, but my solution, my off-the-shelf solution, rounds to the nearest whole number. What did I do with this number to get to reuse that functionality? Okay, what if I moved the decimal point over here and then rounded? Would that do it? Yeah. But am I going to get paid $1,667 in interest? No. So after I round it and get this, what do I do then? I go back and divide by 100. So let's do that in our code. Right? Again, this is an engineering problem too, right? Multiply it by 100, and then after you're done, divide it by 100. When you're doing an engineering problem, when you're designing a machine or something, you look for off-the-shelf components. Right? If you're designing this machine over here and the specifications call for a motor that runs at 3,200 RPMs and it works with this power supply over here, you don't go then, okay, now I need to design a motor, right? Now I need to build a motor. No, you go to an inventory list. And do we have something that meets that specification? Yes, we can order 1,000 units from China for this unit price, right? then let's go ahead and do that, right? We don't have to reinvent the wheel every single time. But maybe this motor doesn't work to our specifications. It runs at 3,200 RPM, but it doesn't work with this power supply over here. So maybe we can put an amp between it and the motor, and now we're good to go. And we still have our cheap motors that are off-the-shelf solution, right? So the best thing to do when you're doing engineering is to look for off-the-shelf solutions, pre-existing solutions that you can reuse and that you can leverage. There are a couple questions? Yeah?
Could we just rinse like to the accuracy of 2 decimals?
You could, but then it won't be accurate. Eventually you'll lose sense or gain sense because you're not actually changing the variable value. You're just making it look like you're changing the variable value until those floating point errors catch up to you a couple years down the line, right? In the table, that is. All right, well, so let's go ahead and check and see if this works now. Oops. Repeat that. All right. Go up here. All right, that all looks great. There's 53, and if you'd done more up on the whiteboard, you'd probably come up with this as well. The formatting doesn't look nice, though. So as a final final update to this, let's update that formatting. If I'm going to go up for 120 months, I want them aligned with 3 columns. It's a dollar amount, so let's go ahead and put in a $sign. And if it's a $sign, how many decimals of accuracy should I have? Just 2. $sign, oops. Just 2 decimals of accuracy. And I want all those periods, all those decimal places, I want them all aligned. So I'm going to say at least 10 columns of output. And now when I do this, I get something that looks quite like a ledger, right? An actual ledger. The $signs are not attached to the numbers. They're out here, but that's exactly how it would look in a ledger book. You'd have the $sign over here. What's really important is that you need all of those decimals to line up there. Right? And now, that looks good. How much money do I make? $25,000 at the end of 10 years, right? Invest in something better. Invest in, I don't know, historical stock market is going to be 9%. And then cross your fingers that you're in a good era. Right? Oh, I don't know. Negative 120. Invest in Bitcoin. Right? The Bitcoin crash has recently crashed, right, over the last month or so. All right. So that looks reasonably good. You probably want to test this with a bunch of different test cases. What if I only got 1% interest over? Well, that's slightly less. What if I got 10% interest, right? Then you're really making money there. What if I started out with only $100 instead, but I promised to go ahead and put in $1,000 a month, and you get stuff like that, right? And of course, you'd have to have a high confidence. You could go into your finance books or just a finance website and find compound interest formulas and compute how much should I have with this much interest after this many years with this many deposits. Plug it into a formula and see if it matches, right? Or if it's close. All right. Any questions? Yeah, up there. Yeah, this will be posted with everything else too. Other questions? Okay, this will be posted later tonight to GIST, and it'll be on Piazza. printing, could you, this is REPL, so I'm not sure, but. Alright, and how did you use WAL? So it'll warn you about that as the number of those formats that we expect double, expected in, but it's not. Because of the undefined, I mean, it's going to print something. It's something. Right, it's printing. You told it to print a floating point number. You didn't give it a floating point number, so it's printing whatever it wants to print. And apparently, let's print zero. Right? It's undefined behavior. You say print something, okay, I'll print something, whatever it wants. Take it to a different compiler, take it to a different system, and it could print something completely different. Yep.
Thank you.
Yeah. At least 10 columns with 2 decimals of accuracy.
Yeah, he's no.
So that, let's see, let's look at the output here. So that what it did is it printed $1,472. That's 4 columns. The period counts, and then the 93. So that's 7 columns. But I said at least 10. So what it ended up doing is prints 1, 2, 3 spaces. That's how you can align it.
Okay. So if I did like 8 with the dollar sign, it would write up.
Yeah, then there'd only be 2 spaces, right?
Yeah.
I did 10 because 10 is safe. There's no, we're not. Yeah, you could, if you want to be really safe, you could go up to 20. I wasn't going to do any numbers that were more than 10 decimals, so, or digits, so. And there's really no way to predict that in the future. I mean, that's just for simple cases.
Yeah.
Right?
Okay, thank you.
Yeah.
Okay, next Thursday, a bunch of us are going to Chicago to visit Google.
Okay.
And so I'm not going to miss a lecture or anything, but we're going to miss a hack.
Okay.
Do you just want us to submit
do it remotely.
Yeah, that's
Okay.
what we were planning on doing. But like,
Alright.
there's just because you have to sign in and stuff. Do you want us to do
Well,
it?
that's just our attendance tracking. So
Okay.
when somebody comes and says, I need an extension on
Okay.
hack 5, and I look at the attendance, it
Okay.
didn't even show up. Why should you
Okay,
get an extension?
so we're good then?
Yeah, yeah.
Okay, awesome. Cool.
Thank you.
Yeah.
I think your YouTube feed for conditionals was like cut off.
Oh, it was?
I think so. One of them was cut off. It was either
It's
conditional.
probably still recording right now, but
Hi.
YouTube within YouTube. On YouTube or VidDrip? Which conditionals? Which one? First or second?
I can't.
Is it over the lecture itself?
Yeah, no,
That's
over
cut
the
off.
like it was literally just
For this course.
Oh,
Oh, well, yeah, I have no, it starts at procedures,
okay.
or the
So I
corner
mean,
cases, the
started
talking like 2 minutes early.
Okay, so
Prompt and then read.
yeah, it's always going to
But most programs are not like that. Most programs.
So at 6.
Well, 6:15. 6:15. So that's why I say it's probably still recording right now.
Oh. All right. I just wanted to make sure that it wasn't like,
No, it's VidGrid. I can ask them to, increase either end 5 minutes or something like that. But then there'll always be like 5 minutes of dead time
yeah.
on either side.
Yeah, I could imagine either that covering, more, whatever you do at the beginning of class, or
Sure.
or it's not going to do anything if there's nothing there to even see. So.
I
I just figured I'd let you know.
Okay,
I don't
sure.
think there's anything pertinent.
Okay.
With this, but
All right.
I mean, because you post a lot of the notes on
Right.
anyway. So.
Okay.
But thank
Sure.
you.
Thanks.
Okay.
Yeah.
So I was working on the second assignment, and
Okay.
I was talking to TAs about it during the lab,